Okay, in this screencast, I'm going to go over the review section on torque. I'm also posting the PowerPoint from the day of torque in case you want to reference that. But I am going to, again, leave it for you to fill out numbers 1 all the way down through 5 because those come straight from the notes. So starting with number 6, one of the reasons I really like torque is it's very, very simple. We're back to a 3-variable equation. So in your question here, it is asking you for torque used to open a door. Given that you've got a perpendicular force, don't worry about that word perpendicular. For CP physics, we always use a perpendicular force. I'm not sure if they do the same in honors. I'm sure that in AP physics they would use angled forces, but we're going to keep it always perpendicular, so don't worry about that word. So 4.2 newtons, all that you really need to recognize again is that that is a force, and it's used to open a door when you are applying that force 6.5 meters from the door's hinges. Start out like any other problem. We know we are given a force of 4.2 newtons. We also recognize meters is our variable for distance, 0.65 meters. Question that I'm asked is, well, what's the torque? My equation for torque, very simple. Torque equals force times distance. That's all you got to do. So we're going to plug in our force 4.2 and our distance 0.65. Remember, if at any time when I'm working a problem you get confused or you remember how to do it, pause and work on your own. That's going to help you much more. So I'm going to multiply these two numbers together, and I get my final answer of 2.73. I have to think to myself, oh, what are my units? Torque is a strange one. They don't give it its own unit to memorize like a force is measured in newtons. Instead, what we're going to do is say that the unit for torque is the same as multiplying the units for force and distance. So our unit is Newton meters. So torque is really incredibly simple. Now moving on to number 7, you'll notice that they give us some different information. This time we're being asked about how long the wrench is if we use a force of 11.5 newtons, and they give us the torque on those lug nuts that are holding the tire to the car of 2.3 Newton meters. Okay, so again, we see that and we're like, ooh, that's a little weird guy. Well, yeah, because he's the unit for torque. So the first thing that they gave us, 11.5 newtons. Then they gave us the torque, 2.3 Newton meters, and we're being asked to solve for the distance. And I can see right up here, I've got this equation. If you want to write it in that way and rewrite the equation later on, or remember your triangle, anytime you've got just 3 little variables, we look up here and I say, well, force times distance, so those are going to go on the bottom, torque goes on the top. I'm solving for distance, so I cover up the D, and distance equals torque divided by force. So I'm going to write that down. Distance equals torque divided by force. Now I can just plug in. I need to look over here and make sure I get my numbers in the right order and that they're not flip-flopped. 2.3 Newton meters divided by 11.5 newtons. Those newtons are going to cancel out. This is why we've got that strange unit, Newton meter. We're solving for distance. You can see the meters right there. This is important because it lets you know that you set your problem up correctly. Now I go to my calculator and I simply plug in and I get an answer of 0.2. Again, if I'm looking for what are my units, I can either look right here, or I can just say, oh, we're talking about a distance. Unit is meters. That was the most missed thing on, this was actually, I think, on your universal gravity quiz, but making sure we got the units right for distance. We just forgot about it because it was so easy. On to the next page. Okay, now we've got our balance beam questions. And most of these are straightforward. The last one is a little bit trickier, but they're set up just the same way. If you remember how to do the seesaw equations, again, pause and work on your own. What I'm going to do is start out by drawing my seesaw because I see this word. And so here I go. I'm going to draw my seesaw. And it tells me that I've got the, well, it actually doesn't say it's fulcrum is in the center, but I know that because it's a seesaw. So I've got two children there. One child weighs 215 newtons. Okay, and he is sitting 5 meters to the left of the center. So 5 meters. The second child is 285 newtons. 285 newtons. Again, newtons, that means you've got a force. The question is, how far to the right should he sit? Well, if we remember, the idea of equilibrium, rotational equilibrium, is that we have to have the same torque on both sides. So torque over here equals torque over here. The equation for torque is force times distance. So force times distance on the left equals force times distance on the right. We're going to just add those little we're going to add those 1s and 2s to indicate which side of the board that we're on. And we're just going to keep everything together. So all I do is multiply the left side, force times distance, has to equal the right side, force times distance. But there's my unknown. So just like I would do with any problem, I can start out by rewriting the equation or simply multiplying out what I've got. It's the same thing, really, same steps. I'm going to put 215 times 5 into my calculator, and I get the answer 1075, and that equals 285 times D. If you see it like this, maybe it's easier to find out what to do next. We got to get D alone, so we can divide both sides by 285. When we do that, I get an answer of 3.77. I ask myself, what are my units? I was solving for distance. Unit is meters. Now sometimes they'll give you centimeters. How do you know which one to use? Whatever they gave you. We had newtons and newtons here. We have meters, so this is in meters. If we looked at it from a unit standpoint, newtons meters gave us newton meters. We divided by the newtons, we're left with just the meters. Okay, if it had been centimeters, we could have done it without converting. On this problem, that's okay. If we have another torque problem, you'll have to convert, but I'll be sure to remind you of that for any questions that appear on the test. Okay, moving down to number 9. Again, this is the same idea. We've got that beam, and we've got the support in the center. It makes it just the same as any old seesaw. We've got an object placed, and you know what? There's a typo here. They both say right. I'm going to change this one to say left. Okay, we're going to place an object 7.5 meters left of the center of the board. And this object is 35 kilograms. We want to know what the mass of an object that balances it would be if that object sat a little bit closer, 6.2 meters instead. So we want to know, how big is this box sitting here? Well, there's a nice little trick that we can do. Remember, I'm just going to take this equation right here, put it down. Remember that a force that we're dealing with in a seesaw equation is a weight, and I get weight by saying, make sure I'm still in the picture, FW equals mg. So really what I'm saying is the mass of object 1 times gravity times distance equals the mass of object 2 times gravity, again that's just my force, times the distance. Well, mass 1 and mass 2 are different. D1 and D2 are different, but gravity is the same. I can cross that out. So all I need to do in this situation is mass 1 times distance 1 is going to have to be equal to mass 2 times distance 2. You don't have to convert it to a force. You don't have to convert to weight. You can do just what you need to do is just like the question before. So if I look at my numbers on the left side, I'm going to say 35 kilograms times 7.5 meters is going to equal that unknown mass times 6.2 meters. Okay? And then I'm going to do the same thing I did before, multiply out the left side. And I got 2625, and this is kilogram times meter. It's a strange unit. It's not the right unit for torque, but you're going to see that it is going to give me the correct answer. And that equals, again, my mass times 6.2. I want to get rid of that 6.2. Let's take them out by dividing both sides by 6.2. And again, it's 6.2 meters, so my meters are going to drop out. So divide by 6.2, and I get an answer of 42.34. What unit am I left with? Kilograms. Kilograms is a mass, but look at the question. The question asked you for mass, not for weight. So this is an important distinction to observe. In the first question about seesaws, we had weight. This time, mass. All right, number 10 is actually a little bit more of a bonus question because they've asked us something a little bit different in nature. This time, they tell us how big the board is. The whole board is 15 meters. So when we draw that fulcrum in the center, what we should know is that there's 7.5 meters on each side of the board. Now this is important because the way that they word the question, they're going to place the object 2.5 meters from the end of the board. So if I chopped off 2.5 meters from 7.5, what's left over? Well, I'm just going to do that quick math right here. I end up with 5. So my real distance here is 5 meters. That's the tricky part about this one. And my object is 40 newtons. I've got newtons, so I'm dealing with force 1 D1 equals force 2 D2. Because there's so much going on, I want to go ahead and write this down. I've got 40 newtons on the left times 5 meters on the left. Let's read the rest of the problem. You've got the fulcrum directly under the center. Where would we put a 50 Newton object? So I've got the weight force, and I want to know the distance. Okay? We can use distance from center. That's the important piece to note. So as soon as we solve this, we're done. The only tricky part was figuring this part out. There will not be a question like this on the test that you have to do. Focus on these problems. Don't worry about this little tricky guy. So if we do 40 times 5, we're going to get 200 Newton meters. And it equals 5. Oh, look, I made a typo. 50. Thought that was something weird. It equals 50 newtons times some distance. So I need to divide both sides by 50. And this is some pretty easy math for me without my calculator. But you guys, don't worry about it if you're using it. Okay, so I get 200 divided by 5, or I'm just not use my calculator and say this is 20 divided by 5, which is 4. Now look right here, 4 meters. Distance It all works out just perfect.